Welcome everybody. We got an interesting question. We are expected to integrate integral x raised to the power of 1 over log x, that is raised to the power of x squared positive y squared times dx. Now we have a boundary condition, x raised to the power of 6 positive y raised to the power of 6 is equal to 26, and x raised to the power of 4 positive y raised to the power of 4 is equal to 10. Now we have to make use of this boundary condition and make sure that we are in a position to integrate this quantity. Now it looks challenging, and let us get it started. So foremost, what we want to do is we want to exactly find out what this x squared positive y squared is. So that's our first step. So let me just consider the given condition. It is stated as x raised to the power of 6 positive y raised to the power of 6 is equal to 26. Now I would be rewriting this as x raised to the power of 2, and that is in turn raised to the power of 3. Positive y is raised to the power of 2, that is in turn is raised to the power of 3, which is equal to 26. So this is the first step. Now there is a formula with the cubic expression, so I'm going to utilize this. So we know that if I were to be given x cubed positive y cubed, then I can rewrite this as x positive y raised to the power of 3 negative 3 times xy times x positive y. If you were to expand this and simplify it, you will get x cubed positive y cubed. So let me put this in the box. So using this we get, so what do we get? This quantity, this x squared raised to the power of 3 and y squared raised to the power of 3 can now be rewritten utilizing this. So this is going to be x squared positive y squared raised to the power of 3 negative 3 times x squared y squared times x squared positive y squared. So that is what we have got. Now this is equated to 26. Let me take x squared positive y squared to be equal to some p and x squared times y squared to be equal to some q. If I were to take this as 2, therefore 2 can now be rewritten as, in place of x squared positive y squared, you got p, that is raised to the power of 3, negative 3 times, in place of x squared y squared, you got q, that is in turn multiplied with x squared positive y squared, which is actually my p. So you have p cubed negative 3 times pq is equal to 26. So let me have that to be as sum 3. Now let me consider this second boundary condition. So let me write that down. Consider x to the power of 4 positive y to the power of 4 is equal to 10. This can be rewritten as x squared raised to the power of 2 positive y squared raised to the power of 2 is equal to 10. Now we know an algebraic identity that has x squared and y squared. So let me write that down. If we were to be given x squared positive y squared, I can rewrite this as x positive y raised to the power of 2. Now we have an additional 2 times x into y, so that is removed, 2 times xy. So this is the identity we will be utilizing. So using this we get, so what do we get? I can rewrite this utilizing this. So this is going to be on the left side, this is going to be x squared positive y squared, that is raised to the power of 2 negative 2 times x squared y squared is equal to 10. Okay, fair enough. So we got that out. Now we already made an assumption that x squared positive y squared is equal to p. So can I substitute that p in place of x squared positive y squared and then raised to the power of 2, and what is this? X squared and y squared, this is equal to q. X squared y squared is equal to q, and this is equal to 10. Now what I wish to do is I will want to take that q out of this 3. So for that I need to get a representation for q. So this is going to be, this means p squared negative 10 is equal to 2 times of q. So therefore q is equal to p squared negative 10 divided by 2. So this is what we've got. So using this in 3 we get, so what do we get? You go to 3, therefore 3 is rewritten as p raised to the power of 3 negative 3 times p. In place of q, I'm going to substitute p squared negative 10 divided by 2 is equal to 26. Now I will multiply throughout by 2, that is going to give me 2 times p cubed negative 3 times p of p squared negative 10 is equal to 52. Now let me go to the next page and actually see what we are heading to. So this is going to be 2 times p cubed negative 3 times p cubed, and then you have negative positive 3 into 10 is 30p is equal to 52. So this is what you've got. Now if I were to add these two things, I would get negative p cubed positive 30p negative 52 is equal to 0. Can I multiply throughout by negative 1? That is going to give me p cubed negative 30p positive 52 is equal to 0. Now what I wish to do is I would like to utilize synthetic division. Coefficient of p cubed is 1, p squared is not there, 0, p is there, negative 30, and then I've got 52. Now what I need to do is find all factors of 52. That is critical. So you need to extract the factors of 52 and place them here, and then apply the synthetic division, and then find out which is going to lead me to 0. Now I would like to use some trial and error method. So let me do that. So if I were to write down the divisors of 52, 1 is a divisor, it means plus or minus 1, then plus or minus 2 is a divisor, then 3 is not a divisor, 4 is a divisor, because 4 divides here one time and you got a 3 there, 4, so 13 into 4, 4 3s are 12, 1 4 1s are 4 5 52, plus or minus 4 is a divisor, and so on and so forth. You don't have to be extracting all the factors of 52 or the divisors of 52, just approximately you locate the factors and then you use trial and error method. So you start with 1, definitely I know 1 plus or minus 1 is not going to be giving me a 0 here, but 2 has the potential, so I'm going to be placing the number 2 here. So I bring 1 down. This is how the synthetic division is applied. 2 into 1 gives me 2, so 2 is added with 0. You don't have to change signs and all, just you carry out the algebraic operations that you see here. 2 added with 0 will give me 2. Now 2 multiplied with 2 will give me 4. Now you have to add negative 30 with 4, so that is going to give you 26 with a negative sign. So 2 multiplied with 26, 6 times 2 is 12, 1, 2 times 2 is 4, 4 added with 1 will give me 5, and the sign here is negative. So this is going to be added together, this results in 0. So thereby 2 is clearly a factor, and when we write the factor, so this means x is equal to 2 is a root. Let me write it like this: x is equal to, in fact in this case is not x, in this case it is p. So p is equal to 2 is, this is the way we write, is a root. So this would mean p negative 2 is a factor. Now that has got nothing else, or I would say it means utilizing this we have actually reduced the cubic to quadratic. So therefore the remainder, this is going to be my remainder polynomial, or in this case is quadratic equation. So this is going to be, this means you have 1 there, so 1 multiplied by p squared, and then you got 2 there, 2 times p, and then you got negative 26. So this is the this is actually the quotient. I cannot say remainder, this is actually the quotient q of x, and the remainder in this case is 0. We got the remainder to be 0. So we have to actually extract the roots of this, and the best way to do or the best way to get the roots for this is by quadratic, using quadratic formula. So I'm going to use quadratic formula. So it's going to be negative b plus or minus root of b squared negative 4 times ac divided by 2 times a. This will give me the roots. So in this case it's p. So negative 2, that's going to be there, plus or minus root of b is 2 squared negative 4 times a times c is 26 divided by 2. So if I were to simplify this, this is going to give me negative 2 plus or minus 2 squared is 4, negative negative positive 6, 4 into 26, 6 4 are 24, 2, 4 times 2, 8, 9, 10. So this is divided by 2. So you got 108, right? 4 and 6 4 are 24, 2 4 2 are 8, 9, 10. So 104, and this is what we've got. Now root of 108, the question is, do we have a simplification technique to get? So this is going to give me negative 2 plus or minus root of 4 added to 104 will give me 108 divided by 2. So therefore another two roots are there. P1 is equal to negative 2 plus root of 108 divided by 2, and P2 negative 2 negative root of 108 divided by 2. Now just to go back and see what we have taken to the value for P as. Now P is equal to x squared positive y squared. So that means this is going to be a positive value, right? You see here, this is a positive value, but here we are getting P2 to be equal to negative 2 negative 10 root of negative 108 divided by 2. So this cannot be acceptable. So there are only two available roots for this cubic equation. So that is P is equal to 2 and or P is equal to negative 2 plus root of 108 divided by 2. Now you can use a calculator and extract the value of P, but I would settle the value of P to be equal to 2. So from here, this would mean, since I've taken P to be as x squared positive y squared, this means x squared positive y squared is equal to 2. So I'm happy to have obtained this condition, x squared positive y squared is equal to 2. Now that is not the end of the story. Why it is not the end of the story? So we have got a quantity like this. We are expected to integrate x raised to the power of 1 over log x, and that is raised to the power of x squared positive y squared. Now what I am going to do is, in place of x squared positive y squared, I would be substituting the value of 2. So 2 goes over here multiplied with dx, but still this is a complicated situation. Now I need to extract what this value is. So let me go back. I'm going to show you how to integrate this. Now we are expected to integrate x raised to the power of 1 over log x. This is raised to the power of 2 times dx. Now let me consider some. I have taken p and q, so I'm going to consider m. Let m be equal to x raised to the power of 1 over log x. Now take log both sides. Taking log both sides, we get, so what do we get when you take log both sides? This is going to be log of m is equal to log x raised to the power of 1 over log x. Now we know from the property of logarithms, log a raised to the power of b is equal to b times log a. So if I were to utilize this, this is going to be 1 over log x multiplied with log x. This is equal to log m. Now whenever we use log, it means we are utilizing log to the base 10. Now log and log gets cancelled. In fact, log x and log x get neutralized. This means I have log m to the base 10 is equal to 1. Now from the property of logarithm, if I have something like this, log a to the base 10 is equal to y, then this means a is equal to 10 raised to the power of y. So utilizing that, this would give me m is equal to 10 raised to the power of 1, which means m is equal to 10. So m is equal to 10 means m has been taken x raised to the power of 1 over log x. So that in turn means x raised to the power of 1 over log x has got a value of 10. So this is what we have found, right? substitute that value. So this means I get integral x raised to the power 1 over log x is now taking the value 10, and that is raised to the power of 2, and this has to be integrated. Now this is nothing but 100, right? 100 times integral of dx, which is nothing but 100 integral of dx gives me x plus arbitrary constant c. Now this is the solution to this beautiful quantity of integral with the boundary conditions that we have been mentioned here. Thank you everybody. Please like, share and subscribe to our channel. Until we meet again.